Hey, 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 it's Patch a Day number 17. And today I'm going to make something which is exactly the same as Patch a Day 16, sort of, but not really. It's for doing the same kind of pitch adjustment, but using the for live performance purposes. So I'm going to start at the bottom this time with my PFFT, and as with last time, we're loading up this abstraction called gadget, and I'm going to give it arguments of 4096 for the window size and 8 for the number of overlaps. And I will need something to play that out through, so I guess I'll go for my trusty Easy DAC. This is starting to look very repetitive to me. I don't know about you, but I'm going to use, because should I use my ADC? That usually gets confusing. So I'll use SF Play with the same message of open Cherokee.aif with a comma, loop 1, so it plays continually, comma, 1 for the playback, actually start the playback. And I'm going to use, instead of changing the speed of the SF Play, you can imagine that's an easy ADC, just to imagine you doing this for live purposes. I'm going to use a tap in of, let's say, 10 seconds, and a tap out as well. All tap ins need their tap outs, there's just no way around that. Tap out with some kind of signal control of the delay line. We can hook that straight into the gadget for the moment. How to control that delay line? Well, let's do something a little bit different. Let's make a rand tilde, which is going to put out ramps of connecting random values between -1 and 1. And for a delay time, we don't really want negative delays, although that would be great if that was actually possible. So I'm going to plus tilde 1.1, so that'll bring it up into the world of, well, 0.1 to 2.1. And I'm going to multiply that by some factor of, let's say, I don't know, 4,000. That won't exceed my 10,000 milliseconds. That's going to go now. Can I even figure this out? 400 to, what's 2.1 times 400? 800, 8,400. Okay. See what I did there. Alright, so now we do ramp. I'm going to do a ramp smooth on this. Ramp smooth is really good for smoothing out lines into nice nice smooth shapes. So I'll just go with the, if you look at the help, that's where I stole those arguments for. The ramp actually happens over samples, so 44/100 might sound like a big number, but that's just 1 second of ramp, and then that's a ramp up value, that's a ramp down. Yeah. Okay, so the ramp smooth will just help us smooth this thing out, and we can basically connect that up to the tap out to see how this thing sounds while we've just got it like this. Alright, so you got some kind of randomly changing delay time, which of course is changing the pitch. So what we're going to want to do is to stick some kind of value in here to adjust that pitch to remain the same. And what I'll do is use an object called snapshot. Actually, there's a couple different ways I could do this. Snapshot is to turn it into the max world, because this inlet here only takes, oh, it does take a signal. Okay. Let's try it with the signal then. I haven't done this yet. This is on the fly. Okay, so we can use an object called delta, which will give us the difference between successive samples of the ramp smooth and what? Yes. Okay, so basically this is the difference in time of the delay that we're producing. And I suppose we're going to want to scale that, since we're looking at, well, let's just try it straight into the gadget and see what that does. Yeah, as I kind of suspected, this is not a signal inlet, even though it says so on the help here. You can see inside inspector, if we know, sorry, that's just going too far, but yeah, if you look inside gadget, you can see that there's no signal input for it. So that would be great. If this was possible, that would probably be the way to do it. Yes, but instead, let's go for a snapshot. That's what I started making, where we look at this every 100 milliseconds and turns it into a float value. It's basically, it's one of the few ways or useful ways of turning a signal into a control value. And as with what I just started there, I don't need the toggle right yet. What I need is to take the difference between successive values. So I'll use trigger float, trigger FF for short, and the minus with a float. Doesn't matter what that value is, it's about to be replaced like there. And then this will be basically the new value gets stored before the next new value comes in and performs this subtraction. So this is just a differencing. We've seen this in several of my in my patch-a-day and the BAS tutorials. Because we're looking at this snapshot every 100, because we're looking at this signal every 100 milliseconds, I'm going to use the reciprocal of 100 to scale those time values to something. Yeah, that's all that needs to be said there, I think. Well, actually, there's probably some serious maths here that I'm really not even understanding, and that'll become obvious in a minute. And if I add 1, that means I am keeping it so that like it's 1 is its normal speed. So that's when snapshot is 0, means the delay time's not changing. And then when I change the delay time, however much it changed over 100 milliseconds, hey, maybe that's the average might be the answer to this thing. Who knows? I'm really getting more and more confused the more I make on this patch. We'll hook that up and we can see that it doesn't really keep it. Alright, it sort of works. It doesn't quite keep the pitch the same. So I think there might be an answer to this through some high-powered maths. Maybe the average is the answer. I don't know. But what I did as a sort of as a kludge, playing around with this for the last 2 hours. No, didn't take that long. Was to basically do some kind of logarithmic. Just change these values to, like, if it's between 0 and 1, means that the speed is lower. Is that right? Well, yeah, the speed is higher, so the pitch is going down. So I'm going to raise that to a power of 0.7, so we make it lower. And then on the other side, a power of 1.7 kind of worked. But again, this was just me kind of messing around to get those values, and it's probably just a complete farce. but anyway, it seems to be a little bit more accurate. All right. So if you know why the pitch changes and it doesn't seem to be uh, co co completely straight here with just this adding one, maybe you can let me know. Otherwise, that was my live delay time thing. I'm pretty sure that phase vocoder example back in patch a day 9 is probably more useful than this, but anyway, I'll see you in patch a day 18. Well,